half wave rectifier. Rectifier means that electronic device which converts alternating current into direct current or unidirectional current. So as a rectifier we use Pn Junction Diode. So alternating current means that current which changes its direction alternately, once positive y direction, negative y direction, positive y direction and again negative y direction. In such a way, the currents which changes their direction alternately, we call it as alternating current. Now, direct current means the current which flows in same direction, that we call it as direct current or unidirectional, means in a one direction only it will flow. Now for converting this AC into DC, we use Pn Junction Diode as a rectifier. Now let us go for the circuit diagram. Now in circuit diagram, this is the input alternating current which we have to convert into DC. Now this is the transformer, the primary coil, the secondary coil. To the primary coil only we have connected input AC. Now this is the required Pn Junction Diode. Okay. Now this is P, this is N, the required Pn Junction Diode, and this is the load resistor. Along this load resistor only we will take output voltage. Here load means output. Load means nothing but output. Now here let us go for the working of half wave rectifier, and why we are calling it as half wave rectifier. Now this is the input alternating current, alternating voltage which we have given to this transformer. Now our intention is to convert this AC into DC. So once let us recall about the Pn Junction Diode. So now already in my last lectures I said that a Pn Junction Diode is having forward bias and reverse bias. So forward bias means here there will be current flow. So here the positive terminal of the battery is connected to the P type and negative terminal of the battery is connected to the N type. Now due to such forward biasing, potential barrier in Pn Junction Diode reduces and high forward current flows in the diode. Similarly, in reverse bias, there will be no current flow. So here, positive terminal is connected to the N and negative terminal is connected to the P-type semiconductor. Due to such kind of biasing, potential barrier increases and no current flows in reverse biasing. So in forward bias only we will find the current. In reverse bias there will be no current. Right? Now here first let us take this positive cycle. Okay? Let us take this positive cycle. So for the first positive cycle of input AC, for the first positive cycle, this cycle of input AC, diode D becomes forward biased. So forward biased means what? Here to P. Now diode D becomes forward biased. Forward bias means here we will have current flow. Means here we are getting output. We will have current flow and here we will get output, and that output is taken along this load resistor RL. Now next, let for now talk about negative half cycle. So in negative half cycle of input AC, diode becomes reverse biased. So in negative half cycle of input AC, diode becomes reverse bias. Reverse biasing means what I said, there will be no current flow. There will be no current flow. So we will not find any output at along RL, load resistor. So now here we are not finding any output in negative cycle. Now if we take next positive cycle, again diode becomes forward biased, current flows, we will have output. In reverse bias, diode becomes, in a negative cycle, diode becomes reverse biased and there will be no current flow. So here if you see the output graph, then what we are finding, just we are finding the outputs only due to the positive half cycles, and there is no output due to negative half cycles, right? Means here rectifier is using only half of the cycle of input AC, so only we call it as half wave rectifier. Why we are using the word half? Because here only half of the cycle, that is positive cycle, is utilized to get output. In negative cycles we are not having any output, only half of the AC is, that is positive cycles are only giving the output. So this is about half wave rectifier.